In this section, we will study orthocenter of triangle. Let's see what is orthocenter of triangle. Orthocenter is the point where altitudes of triangle are concurrent. We have three altitudes of triangle from three vertices. These three altitudes are concurrent, and this point of concurrency is called orthocenter of triangle. Consider triangle ABC. You know how to draw the altitude? From vertex A, we draw perpendicular to opposite side BC. So here is altitude AD. D is called foot of perpendicular. Similarly, we have altitudes from vertices B and C, altitude BE and altitude CF. We can see that all these three altitudes are concurrent at one point. This point is called orthocenter. Generally, we denote this center by H. Now, let's find some angles associated with this figure. First of all, consider this angle. How you find this angle? To find this angle, we will check this angle is shared by which triangles. One of the triangles is this one. It is a triangle AFH. But here we don't know what is this angle. So we consider another triangle. We consider triangle ADB triangle. Now in this triangle, this angle is 90 degree and this angle is B. So what is this angle? This angle is 90 minus B. So we have angle FAH is equal to 90 minus B. Similarly, we can find other angles, say this one, angle HAE. From this triangle, triangle ADC. Okay, from this triangle, this angle is 90 degree. This angle is C. So what is this angle? This angle is 90 degree minus. So here we have this angle 90 minus C. Similarly, we can find all these angles. So let's write all these angles in the figure. This angle is 90 minus A. Then we have angle HBD. This angle is 90 minus C. Then we have angle HCE. This angle is 90 minus A. And then angle HCD. That is 90 minus B. We will use these angles later on for finding some sides of triangle. Okay. Now let's find some sides related to this figure. One of the sides is BD. How you get this BD length? To find any length, you first of all consider that length in one of the triangles. Here we consider triangle ADB. In this triangle, this angle is 90. This angle is B and this length is C. Okay, we can say BD is projection of AB on side BC. We know how to get the projection of one length on other length. Now by solving this triangle, we can get length BD. We have BD is projection of AB on BC. And from triangle ADB, we have BD is equal to AB cos B. AB is C, so we have BD is equal to C cos B. Similarly, we can get other lengths. Okay, say CD. Now CD is projection of AC on BC. Now to get the length CD, we consider triangle ADC. So from triangle ADC, we have CD is equal to AC cos C. That means B cos C. Okay, so we can find all other lengths which are projections. We can find AF is equal to B cos A. Then we have BF, which is A cos B. Then we have AE, which is C cos A, and CE, which is equal to A cos C. Students are not supposed to remember all these lengths. When required, we can solve these triangles to find the lengths. Here it is easier to find the lengths because all the lengths are associated with right angle triangle. Solving right angle triangle is much easier. Okay, now let's see distance of orthocenter from vertex. We will find the distance of orthocenter from one of the vertices in the symmetric form, from which we can find its distances from other vertices also. So here we focus distance of orthocenter from one vertex. For that, consider triangle ABC with altitudes and feet of perpendiculars. Now let's find distance of orthocenter from vertex A. That means we have to find length AH. To find the length AH, first of all we will consider triangle in which length AH is shared. Which is that triangle? One of the triangles. We can have triangle AFH. This triangle is also right angle triangle. It will be easier to solve this triangle. Now we have this angle, angle FAH. Just now we have got this angle. This angle is 90 minus B. Now any other length in this triangle you can find, which we have already found. We have found length AF. What is length AF? AF is projection of AC on AB. So AF length is equal to B cos A. Okay, we have AF is equal to AH cos 90 minus B. Now we put the value of AF, which is B cos A, and cos 90 minus B is sin B. So AH is equal to B upon sin B multiplied by cos A. Now we have adjusted B upon sin B. Now from sine rule we know that this value is 2R, where R is circumradius of triangle ABC. So we have AH is equal to 2R cos A. Now this is symmetrical form. So distance of orthocenter from vertex B is 2R cos B, and distance of orthocenter from vertex C is 2R cos C. Now distance of orthocenter from side. For that, consider again triangle ABC with altitudes. Let's find distance of orthocenter H from side AB, that is FH. We have to find length FH. Again, to find FH, we will consider one triangle in which we can find length FH, that is triangle AFH. Just now we consider triangle AFH to find length AH. Now in this triangle, this angle is 90 minus B. Length AF is equal to B cos A. Now we can solve this triangle for length FH. For that, we use tan 90 minus B is equal to opposite side FH upon adjacent side AF. Now we know the value of AF, which is B cos A. So put this value, and tan 90 minus B is equal to cot B. So we have FH is equal to AF cot B. Putting the value of AF, we have FH is equal to B cos A. Let's convert cot B into cos and sine. So we have cos B upon sine B. So we have FH is equal to B upon sine B cos A cos B. What is B upon sine B? From sine rule, it is 2R. So FH is equal to 2R cos A cos B. Also this length is symmetrical because we can consider FH between angles A and B. So we get cos A cos B. So we can write other lengths by symmetry. Distance of orthocenter from side BC HD is 2R cos B cos C, and HE is equal to 2R cos A cos C. So we have found distances of orthocenter from vertices and sides. Okay, let's see some more concepts associated with orthocenter, that is pedal triangle. Now what is pedal triangle? Now pedal triangle is triangle formed by feet of altitudes. We consider triangle ABC with altitudes. Here D, E, F are feet of altitudes. If we join this feet, we get pedal triangle. So in this figure, triangle DEF is pedal triangle. Okay, now do you see some cyclic quadrilateral in this figure? क्या आपको इस फिगर में कोई cyclic quadrilateral दिख रहा है? I can see cyclic quadrilateral. This angle is 90, this angle is 90. So I can say points F, H, D and B are concyclic. Okay, so we have one circle passing through this 4 points. Similarly, we have other set of 4 cyclic points. One is DHEC. These 4 points are also concyclic. We have one circle passing through this 4 points, and AFHE are also concyclic. So we have these 3 sets of 4 concyclic points. Now what is the use of this study? What is the use of this analysis? Okay, what is angle FDH? We have this angle. Now how you find this angle? Now if you see this cyclic quadrilateral, in this cyclic quadrilateral, this angle is angle subtended by this chord at point D. Now this chord is also subtending this angle. Here B point is lying on the circle. Now what is this angle? This angle is 90 minus A. So this angle is also 90 minus A, because we know that chord of circle subtends same angle at different points of circle. So angle FDH is equal to angle FBH. Angle FBH is 90 minus A. So angle FDH is also 90 minus A. Similarly, we can find other angles, say angle HDE. What is this angle? We can consider cyclic quadrilateral HDCE. HDE angle is equal to HCE angle. We can see that this angle and this angle are same because these angles are subtended by chord HE at different points of the same circle. Now what is this angle? This angle is 90 minus A. So this angle is also 90 minus A. So we have angle HCE is equal to angle HDE is equal to 90 minus A. Now we have this angle and this angle same, 90 minus A. So we can say AD is angle bisector of angle FDE. Similarly, BE and CF are also angle bisectors of triangle DEF. Now, the point where angle bisectors are concurrent is called incenter of triangle. That means here point H is incenter of triangle DEF, or we can say orthocenter of any triangle is incenter of its pedal triangle. Also, angle FDE is sum of these two angles, 90 minus A and 90 minus A, that is pi minus 2A. Similarly, we have other angles of pedal triangle. Angle FED, this angle is pi minus 2B, and angle EFD, which is pi minus 2C. After finding angles of pedal triangle, now we are interested in finding the length of sides of pedal triangle. So consider again triangle ABC with pedal triangle DEF. Now we have sides of this pedal triangle DE, EF and FD. Let's find side FE. To get side FE, we can consider triangle AFE. Now try to find some angles and lengths in this triangle. AF, we have already found in previous discussion, AF is projection of AC on AB. This length is B cos A. Okay, what is length A? Length A is equal to C cos A. This is also projection of AB on AC. By solving triangle AEB, we can find this length A, and this angle is A. Okay. Now in any triangle, if we have two sides and the angle included between them is given, how we can find opposite side? We can find opposite side using cosine rule. So now in triangle AFE, using cosine rule, we have this formula for EF. It is EF square is equal to AF square plus AE square minus 2 times AF into AE multiplied by cos A. In this, now put the values of AF and AE. So we have B cos A square plus C cos A square minus 2 times B cos A, C cos A multiplied by cos A. Now from this we can get cos square A common. So we have cos square A outside bracket, and in the bracket B square plus C square minus 2BC cos A. Now what is this expression? The expression in the bracket. Again from cosine rule, this expression is A square. So we have A square cos square A. So we have EF is equal to A cos A. This is again symmetrical. It is easier to remember this because EF is length opposite to angle A, and its length is A cos A. So by symmetry, we have other lengths, say FD. FD will be B cos B. And what is ED? ED is C cos C because it is opposite to angle C. Let's see now what is circumradius of pedal triangle. First of all, tell me how you find circumradius of any triangle. By some rules. Which rule uses circumradius of triangle? Certainly sine rule. So first of all, consider triangle ABC with pedal triangle DEF. Now we have to find circumradius of pedal triangle DEF. To find this, we will be using sine rule. Okay. Now let's circumradius of this triangle is R dash. Now what is the statement of sine rule? 2R dash is equal to length EF divided by sine of angle EDF. You know that by applying sine rule, if you want to find the circumradius, we need one length of triangle and an angle opposite to that length. Now we know this length FE. Length FE is equal to A cos A. It's a side of parallel triangle. Just we have derived this. And what is angle FDE? Angle FDE is equal to pi minus 2a. Put these values in above formula. So we have 2r dash is equal to a cos a upon sine of pi minus 2a. What is sine pi minus 2a? It is sine of 2a. And we can further break sine 2a in 2 sine a cos a. Further, how we simplify? Cos a gets cancelled out. So we have 2r dash is equal to a upon 2 sine a. Now from sine rule, a upon sine a is equal to 2 capital R. Capital R is circumradius of triangle ABC. So we have 2r dash is equal to 2r by 2, or r dash is equal to r by 2. So we got the result. Circumradius of parallel triangle is half of the circumradius of triangle ABC. So if the circumradius of triangle ABC is given, we can find the circumradius of parallel triangle, which is half of it.